Welcome back, students. In our last video we had completed the questions which are not included in syllabus of section C and D of exercise 2. Moving on with the next two sections, that is section E and section F. The first question in section E, which is not there in the syllabus, is of question number 1. You have been given the probability distribution of the monthly demand of laptop in a store, which is as follows. The demand of laptop is 1, 2, 3, 4, 5 and 6. The probability that they have given is 0.10, 0.15, 0.20, 0.25, 0.18 and 0.12 respectively. Determine the expected monthly demand of laptop and find the variance of the demand. Now we start with the sum. We have been given the probability of the demand for laptop. In a store, we have to find the mean, that is the expected monthly demand of laptop, and also we have to find the variance of the demand. Now, demand of laptop, that is x is 1, the probability is 0.10. We prepared it in a tabular portion this way, when you have with the following columns x into px and x square into px. So we'll be seeing the very first column, that is demand x into px. The demand is denoted by x, probability is denoted into by px. So 1 into 0.10 we get 0.10, 2 into 0.15 we get 0.30, 3 into 0.20 we get 0.60, 4 into 0.25 we get 1, 5 into 0.18 we get 0.90, 6 into 0.12, so we get the answer 0.72. When you total up this entire column of x into px, we get the answer, that is 3.62. So the expected monthly demand of the laptop denoted by ex, that is equal to mean, is equal to sigma x into px. So the total is 3.62 laptops. Moving on further with the next column, that is x square into px. So x square into px, that means we multiply 0.10 again with the x, that is sigma x px into x, we will be getting x square px. So 0.10 into 1, 0.10, 0.30 into 2, 0.60, 0.60 into 3, 1.80, 1.00 into 4, that is 4, 0.90 into 5, so 4.50, 0.72 into 6 will give you the product as 4.32. Totaling up the column of x square into px, we get the answer as 15.32. Now, the variance of the demand of laptop, the formula for Vx is equal to Ex square minus Ex into the whole square. So, sigma x square into Px minus sigma x into Px the whole square. That is 15.32 minus 3.62 the square. The final answer that we get after subtracting is 2.2516. That is the variance, and mean is 3.62. Moving on further with the second sum of this particular section, that is section E. We have two dice are thrown simultaneously once. We have to obtain the discrete probability distribution of the number of dice for which the number 6 comes up. Now, as we have been given in the question, two dice are thrown, so the total outcomes is equal to n is equal to 36. Now we have to find the probability that number 6 comes up. Now for finding out number 6 comes up, we prepare a tabular portion in this form, wherein we have 3 columns: event, the element of u, that is x is equal to small n, and p of x is equal to x. Now we can get 3 possibilities where we do not get 6 in either of the dices, that is x is denoted as 0. We get 6 in either of the toss of the dice, then x is equal to 1, or x can be 2 when both the dice shows 6. So again I repeat, the dice does not get the number 6 is denoted by x is equal to 0. Either one of the tossing of the dice shows 6, that will be x is equal to 1, or we get both 6 on both the dices, that is x is equal to 2. Now, if you see the outcomes over here, when we do not get 0 is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Same way, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 51, 52, 53, 54 and 55. So the total outcomes when we do not get 6, x is equal to 0 is 25 by 36. Now, where the tossing of the dice, we get 6 on either of the dice 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4 and 6, 5. So when x is equal to 1, the probability is 10 by 36. And there is only one chance where we can get 6 on both the dice when x is equal to 2. It is 1 upon 36. So if you total up 25 plus 10 plus 1, we get 36 by 36. So sigma px is equal to 1. Now, putting it in the formula of a tabular portion, this way, the probability distribution of a random variable when x is equals to 0, p of x is 25 by 36. When x is equal to 1, it is 10 by 36. When x is equal to 2, it is 1 by 36. So the total comes to 1. Moving on with our next section, that is section F. The very first sum is not there in the syllabus. So the question is, there are 1 dozen mangoes in a box of which 3 mangoes are rotten. 3 mangoes are randomly selected from the box without replacement. If x denotes the number of rotten mangoes in the selected mangoes, we have to obtain the probability of x and hence find the expected value and variance of the rotten mangoes in the selected mangoes. Now, as we all know, 1 dozen mangoes is equal to 12 pieces. We have to do the selection of 3 mangoes. Now, the probability of selection of 3 mangoes is bifurcating rotten and good mangoes. So, out of 12 we have 3 rotten. So, the remaining 9 are supposed to be good mangoes. Now, when the value of x is 0, that means we do not select any of the rotten mangoes, then the selection of 3 good mangoes are done. When x is equal to 1, that means we select 1 rotten mango, so we select 2 good mangoes. When x is equal to 2, that is 2 rotten mangoes, so it will be 1 good mango. And when this selection of x is equal to 3, that is all the selection of rotten mangoes is done, then we cannot select any good mango. So here we can understand that x denotes the number of rotten mangoes, which can range from 0 to 3, that is 0, 1, 2, 3. Now, the total outcomes of selecting 3 mangoes from 12 is denoted by n is equal to 12C3, that is equal to 220. P of x is equal to 0. No rotten mango is selected as shown in the tabular portion. So, P of 0 is equal to 3C0 multiplied by 9C3 divided by 12C3. So, the final answer that we get is 84 by 220. When P of x is equal to 1, that is 1 rotten mango is selected. So, P of 1 is equal to 3C1 into 9C2, that is divided by 12C3, we get the answer as 108 by 220. Again, P of x is equal to 2. So, 2 rotten mangoes is selected. So, 3C2 into 9C1, that is divided by 12C3. So, we get the answer as 27 by 220. Then P of x is equal to 3. No rotten mango is selected. So, P of 3 is equal to 3C3 into 9C0, that is divided by 12C3. So, we get 1 by 220. Now, the probability distribution of random variable x. So, P of is shown in a tabular form this way. When the values of x is 0, the probability of x is 84 by 220. When it is 1, it is 108 by 220. When it is 2, it is 27 by 220. And when it is 3, it is 1 by 220. If you total up, you get the numerator and the denominator as same. So, the probability distribution of random variables total is equal to 1. That is sigma px is equal to 1. Now, moving on further with the sum, we have to find the expected value, that is the mean and the variance. So, with that, as learnt earlier, we prepare a tabular form with the columns x, px, x into px and x square into px. Finding out the mean first with the tabular form. So, x into px, that is 0 into 84 by 220 will give the answer 0. 1 into 108 by 220 will give the answer 108 by 220. 2 into 27 by 220, that gives the answer 54 by 220. 3 into 1 by 20 will give the answer 3 by 220. So, the total comes down to 165 by 220. Now x square into px, so the value of x square into px is equal to multiplying x into px with x again. So 0 into 0 will give the answer 0. 108 by 220 into 1 gives the answer 108 by 220. 54 into 2 by 220 will give the answer 108 by 220. 3 by 220 into 3 will give the answer 9 by 220. So we get the answer as 225 by 220. Now moving, mean is equal to sigma ex, that is sigma x into px. So the answer for mean is directly from the table, that is the total of x into px. So 165 by 220 mangoes. Variance, that is Vx is equal to Ex square minus E into x the whole square, that is Ex square minus mean square. So sigma x square into Px minus sigma x into Px the whole square. So 225 by 220 minus 165 by 220 the whole square. The final answer that we get for variance is 0.4602. Now the sums we have discussed in this video as well as in the previous video are not to be done in the fair notebook, as they are not covered in the syllabus. This is purely for your understanding. Thank you.